I'll put in the
Oh,
chat box.
okay. I'll wait another minute.
Good morning, everybody. While we're waiting for folks to join, welcome to the CEEPC meeting. We'll get started here shortly. Please put your name and affiliation in the chat box. And I'm also going to drop the link to where all the meeting materials are online today for today's meeting. I think we're still a couple folks shy of a quorum, but Madam Chair, if you want to get the meeting started, we can do so when you're ready.
Okay, great. Well, good morning, everybody. Happy summer, and welcome to our fourth Climate, Energy, and Environment Policy Committee meeting for 2025. So I'm Cindy DeBala. Some of you already know me from the City of Tacoma Park Council, and I was asked to chair this meeting while our chair, Sarah Bagley, is enjoying a much-deserved vacation. So with no objections, we will proceed. And before we start with the main agenda, we have two pieces of business. Please, as Maya has said, put your name and affiliation in the chat box so we know you're here. And secondly, we want to review and adopt the meeting summary from the last meeting, which is in the chat. You put all the materials in the chat, is online. Maya, where is it?
Yes, the link that I dropped in the chat box is, and I can drop it in again, that's where all the meeting materials are online today.
Right. And so if you haven't had a chance to look at it already, you can take a quick look at it. The way we will do motions and seconds is we will make them either verbally or in the chat box. So is there a motion to approve the minutes from last time? Don't all speak up at once. I can't see everybody, so Maya, can you see?
Yeah, you can speak verbally or put it in the chat box. I don't see anything in the chat box yet, though.
Okay.
Just a motion to approve the meeting summary.
Motion to approve.
Thank you. Yeah, I didn't give everybody a minute to look. I apologize. Okay, motion to approve. Motion to second. Motion to second.
Sorry, this is Shannon Moore. I can second. I was trying to find my mute button.
Oh, thank you. Yeah. Okay, so any changes, please do speak up as opposed to the chat because I can't keep track of everything apparently. Okay, any abstention? Okay, we're gonna vote. Any abstentions? Please speak up or put it in the chat. Okay, any no or no votes online or speak up, please, in the chat or speak up. Okay, I'm assuming everything else is a yes, and so I'm declaring the minutes approved. Thank you. Now, we have three really interesting presentations today and time toward the end for everybody to share. So let's get started with the three presentations. So first we have Ms. Sunny Westcott, who will give us a detailed update on the state of the climate. And as we all know, especially after last week, there are lots of examples of severe climate impacts occurring across the U.S. and worldwide. those of you who live near Sligo Creek, I think we broke records in terms of more rain, a lot of rain, real quickly, a lot of flooding. So we appreciate having Ms. Westcott put this in context. She spends a good portion of her professional life tracking of some of the changes that we are seeing in weather and climate. And I'm looking forward to hearing what you have to say. Ms. Westcott, are you?
Yes, I'll go ahead and share
Thank
my
you.
screen.
Yes.
Well, okay, and there we go. So it's gonna load up. I think it shows it's sharing on my end. Do you guys have it, or I don't know, it doesn't look like it is. Oh, there we go. It's just a little slow, I think. Is it showing up or is it still black on your guys' side?
Still black.
Okay, let me try a different sharing method real quick. It says share screen or share other screen, and so I'll just share between the two of them the entire screen. Okay, display and go. Huh. It is loading so slowly. I know that we have the slides on backup worst case scenario if for whatever reason the shared screen isn't loading in. So now it's not showing up, but it shows it's sharing on my side.
Alyssa, do you want to share?
Yeah, I can just do it.
Yeah, we'll do it that way. It's not coming up. Marvelous. Can we make it a full screen? There we go. Cool. Okay, so as we're going to go through some of the different data sets that we now have available, there's some new information that's entered into the realm. I'm sure many of you have seen in the news. It's not just us getting hit with these weather events. We've seen France flood out. We've seen China flood out. The UK just had a flood event 2 days ago. We've had flooding throughout the Middle East, flooding throughout Russia. We've had major storms in Ukraine. So we are tracking that these storm events are starting to intensify on that global pattern where everybody is starting to see too much rain at once and it's overwhelming the drainage basins. Some of the other things that we're going to talk about are some of the changes in the extreme side of the weather on severe thunderstorms. So what we're looking at here with the starting graphic is always where we're at with the baseline temperature against the 10 hottest years on record to be able to look at what our models are and are not going to be able to handle. You can see where the hottest years on record were 10 last year's, and that 2024 being the hottest year on record still remains the hottest year on record, but we are just below it with this year. So we're continuing our pendulum swing outside of that of comfort. If you go over to the next slide, this is just a reminder on why all of this is happening. What we have changing in the atmosphere is happening at the top of the atmosphere, and then it's amplifying the weather events for each hazard that follows. So while we look at surface impacts, they are being triggered by an upper level feature change. And that feature change is that our lows are getting deeper, far more potent. And with deeper lows comes stronger winds, more severe weather outbreaks per low pressure system, more moisture able to be pulled down through the atmosphere down to the surface. Some of the other things you're able to see from this is a change in the pattern for the high pressures. That's where we're starting to see those persisting heat waves, higher than usual temperatures, higher than usual heat and humidity combos. So that's the heat index. And when you have that persisting heat for longer under direct sunlight, you end up with more moisture being held available for when the next low comes in, for it to be able to do significantly more damage. So this is the couple up that we're seeing now. If you go on to the next slide, what we're looking at here is the change in the pattern being the explanation as to why this is happening on a global scale, that these highs and lows, as one triggers, the next triggers subsequently because they are interlinked, they feed each other as horses on a merry-go-round along the northern hemisphere. So if we're seeing deeper than usual lows with more precipitation, more lightning, more wind, hail, tornadic activity, they're seeing it with every low that moves across the northern hemisphere. So this explains why the UK is seeing the same weather events, why Ukraine would, the Middle East would, why India, China, and then back over again to the US. When we're looking at the pattern of the flow, all of our fronts enter in from the east, or I'm sorry, enter in from the west, exit out to the east, and then move off and over to the European continent. So every time that we see one of our storms be far more damaging, we can track it on its path over to them and what kind of amplification it may take from there. If you go on to the next slide, again, just continuing to highlight that trend change that we're talking about from the early 1900s to now, that 1 degree of warming that may have occurred across the entire nation. Obviously, some areas warmed far more than others, but that we're already on this pattern of warmer, there and by with warmer equals more water vapor available. More water vapor available means more severe weather outbreaks. So when you have higher heat, you have higher humidity. That leads up and into the water vapor layer. That water vapor is a greenhouse gas. There and by it does naturally trap in even more heat. So this becomes a self-fueling cycle once it kicks off. So what we're looking at, if you go on to the next slide, is this very interesting phenomena, which is our atmosphere as it warms, as does everything else on this planet, it expands. So as the atmosphere expands, it's pushing on the stratosphere, which is pushing on the mesosphere, the thermosphere, the ionosphere, all of these other aspects of the membranes of the Earth that protect us from space. So as the troposphere continues to grow in height and compress these other spheres, what ends up happening is our lows and our highs can get abnormally intense because we've been modeling them within a set amount of tropospheric height, and that is starting to take violation. So what does it look like when our lows are able to grow even outside of what we thought normal? So this means our thunderstorms are getting taller. It means our clouds are getting higher. It means there's colder air available to come down to the surface, but that also means that hotter air can now make it even further up. So this will continue that amplification on both sides of the house, but it also means our prevailing winds, which usually occur when temperature disparities occur, means that our surface is going to see more persisting wind events. So this means higher peaks throughout different weather events. It also means more persisting breezes in areas as we transfer from high to low. So this means topographical features that would trigger wind, mountains, hills, changes in where our oceans and our rivers meet the land. All of those wind events that are regional are also going to amplify. So out west, we have some that are named like the Chinook, the Santa Ana, the Diablos. All of those will continue to grow. And then over here on the east, our prevailing winds will act as a drying mechanism, which will fuel wildfire threats as we go forward. So if you go on to the next slide, of course, every time that I do any sort of study analysis, I always try to couple it with empirical data. So while we have all these fascinating studies that this has been reviewed in China, this has been reviewed in India and the UK, as well as in the Southern Hemisphere, some of the things to annotate is that we're looking at the barometric swings between the two at the surface across the US. So our automated weather stations have been in place since about World War II. They do 2-minute scans of the atmosphere. It's a massive database that anybody's able to access. It's public facing. And what you can do is you can see that standard pattern of where our barometric averages were and then where they're going now. So you can see the extreme happening at the surface for things like airports, stadiums, universities, all of that. So there's empirical evidence behind all of this. If you go on to the next slide, you'll just see what last year was able to showcase to us were some major events. So we had an extra 657 tornadoes last year outside of our annual average of 1,200. So that means we superseded 1,800 tornadoes. What we're looking at for abnormal warming is the Great Lakes regions 1, 2, and 3, which is our Northeast down to our Mid-Atlantic. Those are where we're warming the fastest outside of average. What does that yield in the way of destabilized atmosphere? It means that more severe weather is capable of doing more damage, which we saw throughout the billion-dollar disaster graphic for the last couple of years. These severe weather events are pushing into areas that were not hardened for them because the severe weather events didn't used to occur in those regions. So if you go on the next slide, what we're looking at as far as atmospheric studies go is a 5-fold increase in the area affected by straight line winds, and that these winds are going to increase at a rate of 13% per degree of warming. So if we've already warmed about 1.5 degrees, almost 2 degrees, we're looking at a very notable amount of increase in the prevailing winds and the peak winds, as I mentioned. So these studies are listed out. You're also able to see where our severe weather last year was reported. Again, the Rocky Mountains play a large role in why the US leads globally for severe weather. So we not only have the largest area for severe weather, we have the most tornadic activity, and we have the most frequent hail events out of every other country on the globe. So we are the study basin for everywhere else. If you go on to the next slide, a big part of the atmosphere getting taller is that it pushes on the ionosphere a lot more. What is in the ionosphere? Electrical charge. What does that do? It allows a lot more of this sort of feed in of height. And what that does is it allows our ice to interact a lot more. that allows for more lightning strikes. So for each degree of warming, our storms are more destabilized. They're able to get taller. Subsequently, more lightning strikes are going to be coming down to the surface. So per degree of warming, you see a 12% increase in lightning frequency. However, that translates to cloud to ground strikes increasing about 28%. So if you think there's been more lightning recently, you're 100% correct. We are also expecting for this lightning to be heavily problematic this year should a tropical cyclone merge with the frontal boundary over regions 1, 2, and 3 because of how hot and unstable the atmosphere has been in this area against average. So if you go on to the next slide, there's a fantastic new product out there that allows you to interact with the lightning density across the US as well as globally, where you can see on that graphic that we really lead the way in lightning strikes for dense population areas. Now, of course, the Amazon rainforest gets a ton of lightning strikes, but it's not as developed. Thereby, we don't have as much study on what those lightning strikes do to the electrical grid of the Amazon rainforest, but we do have some fascinating studies on what it does to trees. So when we're looking at the damage in our areas in the cloud to ground flash density, you'll notice, of course, the Texas, Louisiana, Florida areas are our most highlighted because tropical cyclones, but we're starting to see an increase in the region over here between New York, Pennsylvania, down to Maryland and Virginia. So as we're talking about these events, as they push into the region, it's something to keep in the back of your mind. If you move on to the next slide, one of our main contributors to lightning strikes is actually surprisingly pollution. So the more pollution that we have, and this is pollution as a particulate in the atmosphere, not pollution in the sense of the politically charged term. This is actual, the scientific particulate that's in the air does add to the destabilized nature of the thunderstorm, thereby leading to more lightning production because it divides the electrical charges in the cloud. This gives more space. Lightning can travel a little bit further. So the more metro centers that see these kinds of severe weather events, the more lightning strikes they'll actually propagate from the heat of the city, as well as the pollution within the heat of the city, because what does heat do? It expands the air parcel to be able to hold even more. So while it holds more liquid for the rainfall, that's one, but the other side of it is that it amplifies our lightning. If you move on to the next slide, you'll also notice that our hail is getting far more notable in events. And what we're looking at with these hail events is that they are getting more dense. They are also getting larger. So this becomes incredibly problematic for operations just across the board, that we're seeing that the US is really leading the way in frequency of melon-sized hail in the Central Plains. Our record currently is the global record for largest hail size, and that's out of South Dakota from 2010. And that is bowling ball sized hail that's more than 8 inches in diameter. Now, you may say, well, Sunny, that was back in 2010. Maybe things have changed since then. No, a couple of weeks ago, Texas actually got very close to that record with a piece of hail that was just over 7.2 inches in diameter. And that came down as a form of grapple, which means it was a malshaped stone. It wasn't fully round, which can do far more damage when it hits something because it's able to stay together a lot better. So you'll also notice that as our cloud heights go up in atmosphere, because the atmosphere is getting taller, that this will enable even larger, more record-setting hail events as we go forward in the next couple of years. If you go on to the next slide, you'll see a picture of that beautiful hailstone that came down in Texas, and you'll also see some of these other nuggets spelled out of most recent events: 2010, 2016, 2022, 2024, 2023 to 2025, and then of course this 7.25 inch diameter stone as it all fell down. Now you'll notice that insured losses are going up through the roof associated with these hailstones. So some of the insurance companies are starting to pull off of insuring against hail in some areas because it is now going to be a reoccurring phenomena year over year worsening, and it's going to be very difficult to recover on the back end of it because it's going to cover such a large area as we go forward. So looking at hail, looking at lightning, both increasing, looking at tornadic activity, having already increased last year. If you go on to the next slide, what else can be in store? That's right, more instances of 3 to 4 inches of rain in an hour. Now, I went through and collected our records to be able to show you what the atmosphere is capable of doing to us, because I feel like sometimes we forget, which is that in Mississippi, not Mississippi, Missouri, we saw 12 inches of rain in 1 hour, devastating event in and of itself. And that was in 1947. The highest known 1 minute total is in Maryland at 1.23 inches in 1956. That's in a minute. So when we're looking at the 6-hour rainfall record in Pennsylvania at 34 inches, we would think that would be Florida who would carry that record, but it's not, it's Pennsylvania. So this puts a lot of these impacts in our latitude area of concern for the DMV. So it's important to understand that when we're saying 3 to 4 inches of rain occurring per hour for some of these storms, means multiple storms are capable of doing it, not just the storm event, but the storm cell itself is capable of producing devastating rainfall rates. So when we're looking at why is this happening here, how are we flooding out so frequently? We have had instances historically where the atmosphere could hurt us. And now that it's warming, we're seeing more cells capable of doing higher and higher amounts of damage to push on those records. But as a more reoccurring event, this means one after the other, as opposed to one singular instance back in the 1900s. So as we encroach upon this, we're going to see that over the next 3 to 4 years, these events will continue to breach. What does it look like to see a 5 to 6 inch per hour rainfall rate per storm, meaning that back-to-back storms would become far more devastating for our region because of the way we've built our infrastructure. If you go on to the next slide, where we're at so far with 2025's annual preliminary reports, wind is only beat out for record-setting year by 2011. So when we're looking at what years were worse for the US, we are currently in the top runnings for that, and we're in the top 3 years for tornadic activity. Of course, last year is still beating us out, but 2011 being our only devastating area of comparison. Outside of that, we're definitely leading the way. You'll notice that March set a new record for 300 tornadoes. April produced twice as many tornadoes as average. May produced record tornadic activity in the sense of EF3s and 4s further to the north than ever reported. And then, of course, what we're seeing here is that June produced some pretty devastating tornadic activity. If you go on to the next slide, you'll see that those were up in the northern plains for where our tornadoes were able to set down powerful EF3 wedges. What else happened in June? We had a 2.2 mile wide tornado in Texas. Now that's not a record. What's our record? Well, a couple of years ago, Oklahoma produced a 2.6 mile wide tornado. So when we're looking at what does that mean for towns and preparedness, it's impossible to find shelter in a town when the entire town is in the tornado path at that rate. So when we're looking at devastation from these events, this is occurring in other countries with tornadic activity, but again, we're going to set pace for everyone else. So it's important to look at what's happening in the US when it comes to severe weather to be able to plan for supply chain disruptions, because these events are starting to become disruptive in the manufacturing districts in China. So in looking at importing, where are products coming from and where do they co-locate as far as backup? When we're looking at temperatures, you'll also notice if you go on to the next slide, when I say that this is a self-fueling cycle, it is because every continent is reporting an abnormal increase in temperatures, which is fueling these events. They're seeing lightning strikes taking out dozens of people to the hospital because these events are starting to occur at faster and faster rates. So we're seeing it during soccer matches. We're seeing the strikes are carrying further away from the storm cell itself. Now, to be aware, lightning cannot occur without a thunderstorm cell. So any reporting that you see on that is false. Lightning requires an updraft core, thereby has to have a core somewhere nearby. So when we're looking at some of these flood events that are going on in South America, this will help us plan for what our winter is expected to be. Both South Africa and Australia have reported one of their coldest Junes on record after having some of their warmest May temperatures on record. So that pivot between extremes is definitely what we're expecting going forward for our winter. If you go on to the next slide, some of the damages that we've already seen from June, you'll notice lightning strikes last summer in Virginia, the 60 data centers with the lightning arrestor trigger. That's an important thing to keep in mind because drones in UAE were being tested to do lightning pulses into the clouds to trigger rainfall, which means if you were to utilize a drone to trigger lightning or an electrical pulse, not trigger lightning, but to trigger an electrical pulse next to one of these lightning arresters, now that it's made its way into the news, it's a good way to be able to disrupt data centers going forward. Just something to keep in the back of your mind. Other things, Brazil got struck by lightning at one of their data centers, completely took it offline. So this is becoming a greater issue. We're also seeing, of course, our preliminary count for tornadoes is over 1,300, which means we already have an extra 124 against average, and that's where we're starting to see that record tornadic activity. And then, of course, we're already at a $12 billion disaster rate as it stands right now. That number has gone up a little bit further. We have some pending, but of course, the $1 billion disaster graphic has been discontinued. So you'll just continue to have to get this information from Yale or the European side of the house as they're reporting. If you go on to the next slide, we're just going to end on Three additional nuggets to keep in the back of your mind as we go forward, which is that tropical cyclones in Australia this year did some pretty substantial damage. They saw 2 million lightning strikes in one city in 24 hours from a decaying tropical system as it made landfall. They also saw 3 feet of rain. So we also saw down south a storm that went from non-existent to a Cat 5 in less than 36 hours. So what we're starting to see from these tropical events down south gives us a good indicator for what the atmosphere could produce for us up here in the northern hemisphere. So we're continuing to keep an eye on some of the records that are getting set. And then of course, our abnormally warm sea surface temperatures. Where are our currents? Where are our eddies? If we get a tropical wave over one of those, it will grow it. Other things to keep in mind on the next slide, we are subsiding in this region. We are sinking in. You see it in the sidewalks, you see it in the roadways, you see it in the coastline. We are starting to compress at a greater rate. The data center alley is also compressing. New studies have come out. There are ways that you can map this better using INSAR mapping on drones if you feel inclined. But new studies have come out that says that we are sinking faster than we originally anticipated we were, either from an increase in groundwater pooling or just better resolution in mapping. These are things to keep in mind as we go forward, because these flood events will continue to show us where we're sinking the most, because those areas will become the new lowest lying area, thereby where water flows to in order to drain. So as we continue going forward in worsening flood events, keep this in mind. This is also a really good reason as to why the New York City metro system is flooding at greater and greater rates, seemingly year after year. After each flood event, that flood water is incredibly heavy. It pushes that soil down even further, amplifying the subsidence there, and by making it even lower than it was pre-flood event. And then on the next slide, just one final threat for everyone to keep in the back of their minds. Those electric scooters, while a nuisance because they exist on the sidewalks and trying to walk on, they're also out there through the heat, through the cold, through the floods, often not being considered. And in other countries which had adopted them before us, they're starting to see them explode. They're also starting to see the personal mobility devices, because the lithium ion batteries don't like heat, cold, or floodwater. We're starting to see those are also exploding, both on their way to airports, they're exploding at homes, they're causing fires. So everything that we have a concern about for the electrical vehicles should also apply to all electrical mobility devices, because lithium ion does not like floodwater, extreme temperature pivots, or persisting heat from especially these roadways as we go forward. So it's just something to keep in mind, because we are seeing the statistics in the UK creep up to match that of India. I know a lot of people think, well, our scooters aren't the same scooters as India, but they are the same scooter system as the UK. So that's a good comparable nugget for you guys. On the final slide there, next slide. On the final slide, you're going to see where we're at as far as those temperatures. When we said we wanted to keep it below 1.5 degrees to prevent some of the stuff, we're already past that. We're going to continue past it. So at this point, the goal is resiliency as well as mitigation for the future, in the sense of pulling back some of these extreme wobbles in amplitude of events. So that's everything from me as far as all of the fun new studies. Why what's happening is a big part of the messaging. So remember, as the atmosphere gets taller, it can continue to surprise us. Thank you so much. Pending any questions, that concludes my brief.
I'm stunned. Thank you very much. That was a lot of information, all of it very scary to me. And so we have 10 minutes for questions, and I imagine there's a ton of them. What comes to mind immediately for me, this is not a question, is so what do we do, particularly looking at the economic impacts to the region? Do we accelerate the work we're doing, or do we change tact altogether? Not a question for Ms. Westcott necessarily. Any questions or comments from the group? Maya, are you able to see everybody?
Yeah, we have some questions coming in the chat.
Oh, there we go in the chat. Okay, so Matt Rice looks like he's the first one.
Yeah.
Yeah, thank you. Okay, Matt, you want to ask your question, or shall I just read it?
No, I'll jump in. Thank you. Just right at the end there, the e-scooters and e-bike bomb risk. And I realize you're meteorologist, not maybe not your expertise, but Does that extend to electric cars as well? Is it the same type of battery there?
It is better casing for the vehicle batteries. They've done a lot more testing on the separation of each of the batteries, but to keep in mind that the electric trucks is a great example. The Chevy Silverado EV that came out is a row of batteries that extends from the front of the car to the back of the car. So if even one of those becomes compromised, it compromises the rest. So we've seen with the floodwaters with some of the EVs that they do catch fire. That's a notable thing with saltwater, so coastlines. But the other side of it being that the high heat temperature fluctuation can catch both an EV on fire as well as the charging station. So some of the charging in the homes where there's not airflow, and it ends up becoming a very unstable temperature inside the house in the garage. We've seen the explosions from those as far as they short out, they catch fire, and then they catch the house on fire in Virginia. There's been a couple of instances. We've also seen them in the Carolinas, and we've seen them starting to become a greater concern further up the coastline. Some of the new electric homes that are coming on market, they've put those same Tesla batteries that we're concerned about in the basement of the home, and they've put about 3 in there to power a home. So remember when we had the issues with generators because of the concerns of floodwaters and the generator, we're going to run into the same concern of these batteries being exposed to floodwaters and then temperature fluctuations for damaging or the casing of the battery. So with lithium ion in the bikes, there's not a whole lot of space to put extra casing. It would weigh the bike down further. So the battery is easier to compromise, but it does showcase that if the casing it gets too hot in general, that this can be a threat. So as the cars overheat from the roads being hotter, the EV itself, because it weighs about twice as much as a standard vehicle, causes the road to get even hotter than usual. And then, of course, because the heat gets trapped underneath the vehicle while these tires are producing more friction than usual, you're going to see that same amplification for the battery under the vehicle. So there are new studies that have come out that said it twofold. It's going to take longer to charge the EVs going forward, and they're going to lose their range pretty substantially because that battery degradation is going to start setting in. So most EVs lifespans at full maximum capability in non-extremes is usually about 10 to 15 years from what some of those new studies have come out to say, but in the extremes could shorten down to 5 years before you start to see those ranges really drop off.
Okay, thank you.
Not to say I'm against EVs. I want to make sure I emphasize that. I just want to be realistic.
Yep, gotcha. Thanks.
Okay, other questions, comments?
We still have more coming through on the chat.
Oh, okay. Thank
Dr.
you,
Olawale,
Maya.
I'm not sure if Sunny got to answered your question, but I think he was up next.
Did you want me to ask the question?
Yes, please.
Oh, yeah. I wanted to ask, what does this mean for electrification efforts? Thanks for the presentation.
Oh, yes. You're welcome. The electrification side of the house, I know a lot of areas are saying we should underground. It prevents the disruption to the transmission lines. The flooding is a concern for substations as well as nuclear power plants for cooling efforts as well as operations. The subsidence is a threat for transmission lines, for the pipelines, for the undergrounding in full. So it is a growing problem that the energy sector, I feel, has at least become more and more aware of very rapidly. Some of the efforts on the innovation side of the house are looking at different ways to make the casing for the wiring underground to be more malleable, to be able to sustain through the subsiding compression as opposed to encased in cement. So when we're looking at why our pipelines continue to burst often, both the push-pull, the pressure, as well as the ground pushing on it as it subsides. So there is an innovative side of the house that's missing in the sense of we don't have the solution for how to keep energy at the best capability without disruption during these events. We're going to continue to see more disruption, likely covering larger areas because these storm events are superseding what they can model for. So I would say they did a great job if we were going to continue with storm events of the past. But because these storm events are continuing to show us that they can do greater and greater areas of outages, which we've seen more recently, longer lasting outages as well, that this is going to become more damaging in the sense of what happened in North Carolina, where their entire electrical system got ripped up and needs to be completely reinstalled, is going to become more common than we're ready for in the next couple of years as these storm systems take on multiple features. So I don't have anything positive there except for to say it's going to become very difficult, and investing in diversifying energy is the best route, because if you only have one, then that's putting all your eggs in one basket, as we saw with quite a few different things throughout history. If you put everything in one basket and that basket tips over, you're often left with nothing. So recommending diversification to the best of our abilities.
Okay, in the chat, there's a little bit of discussion about, it looks like a couple of questions in the chat have been answered in the chat by Jeff, thank you. And I have a question. Is there such a thing as a data source that can be used to update the predictions that we have all these models that predict what's going to happen, and they're all out of date even as we're speaking. What is the latest that, particularly for regional, more smaller scale impacts? Is there such a thing?
Yeah, so the automated sensor graphic I showed at the very beginning, the ASOS system, those are the most hyper local continuous data set that we have available, and it's open, it's public facing, it's paid for. The more sensors you have, the better. So the Mesonet systems that are being established, New York's got one, I believe Maryland's got one, New Mexico's got one, Puerto Rico's getting one. Every state's moving towards a Mesonet, which is just a interconnected system with these upgraded automated sensors. So the automated sensor network creates this consolidated database of every weather event that you've experienced in that 2-minute slicing, where you would be able to train, and this is where I think AI holds the greatest key going forward. You would be able to train the AI what is a METAR, which is how we encode those weather observations in just text. So it's a very not data heavy data set, and that's great because it doesn't take up a lot of space. So what you're able to do is train the AI to say, how many wind events have I seen at this particular location over 65 miles per hour since you've begun recording? And it'll tell you how many times you've seen those events, and it'll tell you if it's increasing, the rate at which it's increasing, the frequency in which you're seeing it now is great. And you can take those dates that are listed and you can have AI go out and pull the headlines from those events to say, when we see winds over 65 miles per hour, these are the types of damage margins we could see. So if it's increasing at a rate of 46% in this county, then we need to start investing in hardening against winds over 75 to be able to stay ahead of it. So adding the amplification on is a missing component for some of the modeling. So when you're looking at utilizing the models as it stands right now, even the AI models just use the European, in all honesty. So when they say they have this latest and greatest, it's not a new model set, it's just refining the European model. So looking at your most hyper local, what you have historically seen, helps you a lot with being able to understand impacts, as well as understand what to look to build against, so that you make the most out of the grant money or whatever available funding that you have, that you're able to say, we're worried about winds, worried about rainfall events over 4 inches, we're worried about tornadic activity, hail events are all recorded in there. You're able to look at temperatures, dew point, humidity levels, all of that, to say, if we're seeing it at a rate of X, let's amplify for the next 10 years. If we've already seen it at 26% in the last 10 years, if best case we continue on this trend and we don't get any worse, what could we see in another 10 to 15 years? So taking that and sort of flip-flopping it, adding that into the model, I think is your best way to get the most hyper localized focus on what's happening to your region, as opposed to looking at, like, the National Climate Assessment does a great job, but it does stay very high level.
Great, thank you, that was very helpful. Seeing no more questions, and it being time, I'm gonna move on. Thank you, Ms. Westcott, that was fabulous. And if there are more questions, that put them in the chat, and staff will ask Sunny to answer them. So our next topic, which is related, is integrating updated flooding data into vulnerability assessments. I'd like to welcome Catherine Raynon to brief us on her work with the Transportation Planning Board's vulnerability assessment. Catherine is a TPB planner, and some of us have worked with her before. Catherine, there you are.
I'm here. Can you all
And
hear
your
me?
slides are up. Take it away. Thank you.
Thank you. Can you just confirm that you can hear me?
Yes.
Okay, great. Okay, so an amazing presentation by Sunny that leads nicely into this presentation. So I'm glad that she went first. And so good morning and thank you for having me here to the committee. I'm going to provide an update on some of the things that we've been working on at the Transportation Resilience Planning Program at CPB. And so you can go to the next slide. So this is just a brief agenda of what I'm going to be going over in today's presentation. Quick overview of some of the resilience work we've done at TPB to date to sort of just level set, since this is a COG committee. So I know a lot of you haven't seen all of my presentations in the past couple of years, leading to a review of some prior analysis that we have done to understand which transportation assets in the region may be at risk of flooding, why that wasn't totally sufficient for me, and what we did to fill in some of the gaps with an updated analysis, and then wrapping up with some key takeaways. Next. So this infographic really represents where we've been at TPB over the past 5 years with regards to transportation resilience planning, and then we're going to zoom into where we are today and what future work will hold. So integrating resilience into natural hazards into long-range transportation planning really began in earnest in 2020 when COG and TPB adopted the goal of becoming a climate-ready region and making significant progress to becoming a climate-resilient region by 2030. And each year since we adopted that goal at TPB, we have tried to make some steady progress. In 2021, we developed the TPB Resiliency Study and integrated resilience into Visualize 2045, which was our long-range transportation plan for the last 5 years. And we are working on updating that now with Visualize 2050, in which we're also integrating resilience into that too. So that helped inform some of the work that we completed in the following years since I was hired at the end of 2022. So we really began to build on that initial study with a webinar series that engaged member agencies on building capacity and advancing resilience efforts. And then during 2023 and 2024, we really hit the ground running with a resilience forum, a risk-based vulnerability assessment, and then an associated interactive mapping tool, which I will talk about a little bit today. And the Transportation Resilience Improvement Plan, which tries to set us up for a federal highway grant program, and then associated priority resilience project list. And then we did form the Regional Transportation Resilience Subcommittee, which meets quarterly. And I do see several folks who are on that subcommittee in today's subcommittee meeting. So this presentation you may have seen parts of before, but I have added some new things since you've seen it. So it's somewhat fresh. Next slide. So during the course of completing that vulnerability assessment and the trip in 2023 and 2024, the working group of stakeholders identified an interest in better understanding potential flood risk in our region. So that really became one of the focuses of the program for this fiscal year. So just sort of a summary of what the original vulnerability assessment found. It showed that roughly 14% of our roads and highway miles, 4% of bus stops, almost 7% of rail stops, and 39% of rail line miles in the region were at risk to coastal and riverine flooding using FEMA floodplain data. While FEMA floodplain maps are a national data set, that is one of the standard ways of completing this type of analysis. It only shows where flooding has historically occurred near rivers, streams, and creeks. And our stakeholders, rightly so, were telling us that they knew of flooding events that were happening that were not showing up as at risk in this analysis. And so that told us that this initial analysis clearly wasn't telling the whole story, and we needed to do more. Next slide. So for the sake of this presentation, I wanted to take a brief step back to talk about different types of flooding that our region experiences. I know this is this Climate, Energy, and Environment Committee, so I know a lot of you already know this, but I did give this presentation recently to our Transportation Planning Board last month, who is made up of lots of different types of folks who focus on lots of different things. So putting these slides together was really a reminder that not everyone that receives this information is an expert on flooding and the different types there are. So I thought it was good to include this in this sort of general presentation. So I'm going to buzz through it really quickly because I know you guys know what I'm talking about. So this here is a photo of an event that occurred in 2020 in Prince George's County, flooding on Route 50 after an extreme storm. This spot where this occurred was in one of those FEMA floodplain areas. So this is considered riverine or fluvial flooding, which happens when the water level in a river or stream rises, overflowing onto neighboring land, usually due to excessive rain or snowmelt. This area does show as at risk in our initial analysis, so it checks out that this area would flood during an extreme event or high tides. Next slide. We also have sea level rise and the associated events that occur in our coastal areas. So this area of Old Town Alexandria is both in the FEMA floodplain and it's also impacted by future sea level rise. So when conditions are just right, high tides can prevent effective stormwater drainage, leading to flooding like this that we see here on King Street in Old Town. And then next and last example of this for today, we have urban flooding or pluvial flooding, which is caused by heavy rainfall that overwhelms stormwater management systems independent of overflowing bodies of water. So not near any rivers or streams. This type of flooding is not captured in the original risk-based vulnerability assessment that we completed, since it is not captured in the publicly available FEMA floodplain data, because that, again, only takes historical events into account. It does not take future changing conditions into account. And so in addition to this picture that you see here from a 2022 event on Rhode Island Avenue, this is what we saw in our region just a couple of days ago, and what we've seen actually pretty much weekly over the course of this summer. In this particular image, the new tunnels have been completed since these events in 2022 and I think 2021 that have addressed the stormwater issues and on Rhode Island Avenue and then also in Bloomingdale. But these again are just examples of previous serious flooding events that have occurred in our region, but are not captured in the FEMA floodplain data because they are not near rivers or streams or near the coast. And now I have a plethora of examples in addition to the recent Rhode Island Avenue examples that I'll talk about later, but will be coming up in future slides. Next slide. So with the input from the stakeholders and looking at this data and these discrepancies, we really started to ask, how often is this happening in our region? How much information is not being captured in our resilience plans if we're only using FEMA data? So I set out on a project with our GIS team to try and get an actual visual representation of why this analysis is important. And so what you're looking at here, there's a lot of noise in these maps, but this is a preliminary analysis using data from a data set called RIDIS, which is a database that automatically pulls in information from multiple transportation agencies to provide an enhanced overall view of our transportation network, roads. In this example, this is only roadways, which is run by the University of Maryland, this data set. And so for this project, every dot on this map represents a reported event of flooding on a road from 2008 to 2024. So really anytime a road was closed or had some other issue due to flooding. So on the map on the left, you can see all the dots. There are roughly 5,600 total events as seen on this map. And you can see both gray dots and red dots. And so the red dots represent the events that occurred within a FEMA designated floodplain, while the gray events are reported events that occurred outside the floodplain. And I also added a second image of just the events that occurred within a FEMA floodplain on the right, so you can really see the difference there. There are some limitations to this data set, so it's not a perfect analysis, but it really matches up with a lot of the reports that our stakeholders were saying that a lot of assets in our vulnerability analysis were not showing up as risk due to the data set that we were using. And so this visualization shows that less than 15% of the reported events have occurred within a delineated floodplain. So it just sort of doubled down on what we were hearing from our stakeholders who were observing these things happening in their communities. And we wanted to get better information to sort of more accurately show what transportation assets might be at risk due to flooding from extreme precipitation, as well as the potential for increased impacts in the future. So, next slide. The goal of this new analysis that I'm going to talk about for the rest of this presentation was to improve our understanding of future inland flood risk and increase the region's resilience and long-term planning. We wanted to really broaden our understanding of what transportation assets in our region are at risk to inland flooding. So next couple of slides, I'm going to talk about the methodology. Okay, thank you. So there are several ways to get better data on pluvial flooding, including several, we'll quote, off-the-shelf data products. For a lot of reasons, along with our consultant ICF and the excellent expertise and feedback from our subcommittee, we selected Fathom US flood maps and acquired the data for our region. Again, the important thing to note about this data is that it does provide additional forward-looking understanding of both pluvial and fluvial flooding that complements the original present-day FEMA-informed analysis. Next slide. Just wanted to mention quickly how we did this analysis, so the methodology. We worked with our consultant, ICF, to develop an updated temporary flooding exposure rubric using floodplain extent and depth data from this Fathom dataset, just like we did during our original trip vulnerability analysis. We scored each transportation asset in the region from 0 to 3, 0 meaning no exposure and 3 meaning the highest exposure from inland flooding. The flood extent and flood depth here, since we did have depth information, were assigned a 50-50 weighting scheme, which is a little different than our previous analysis since FEMA data does not have any depth information. So that was 100% flood extent. And then we looked at 4 different time horizons. Historical, which is 2020, that's a comparison, direct comparison to FEMA, which is also historical. Short term, which is 2030, and then 2050 and 2080 as our long term. And we did look at 2 different greenhouse gas emission scenarios for future. We did moderate and high emissions, and we used SSP 2 to 4.5 and 5 to 8.5. Next slide. And so we kept the exact same methodology for calculating that risk score as our original risk assessment, so we would be able to compare all the analyses sort of one-to-one. And we took that score that we calculated on the previous slide for exposure, and then weighted that at 70%, while criticality of the asset was weighted at 30%, and that's how we got the final risk score for each asset. So as a reminder, the assets that we analyzed are roads and highways, bus stops, and rail lines. And once those assets were scored, they were classified as having a high, medium, low, or no risk, which is the same as the vulnerability assessment. And just here on this slide, you can sort of see an example of the risk categories shown. This is sort of screenshot of downtown DC in Northern Virginia for the risk scores for inland flooding due for roadways. And so the next several slides, we're going to go through a lot of screenshots of this same little area with various assets turned on and off. So next slide. So like I said, results. We can go to the next slide. Yep. So we did develop 2 products from this analysis, and when I stop speaking, I will send links in the chat to them so you can review them on your own. So we have an addendum, which is published alongside the vulnerability assessment and our trip. And then we also updated our interactive mapping tool with all of the new results. So these products are here for us to help improve decision-making in our region when choosing which projects to prioritize for funding and what type of design and construction methods members may want to consider for new projects based on potential risk for interior flooding. Next slide. So some key takeaways from this analysis is that there are more transportation assets at risk to temporary flooding based on the Fathom-informed analysis relative to the FEMA-informed analysis across both historical and future time horizons. Again, this just reflects how the Fathom data captures expanded floodplains by accounting for pluvial flooding and that projected expansion of floodplains due to heavier precipitation and stronger storms in the future, due to a lot of the things that Sunny talked about in the previous presentation. Next slide. So we're going to be looking at this general snapshot of our region, but with a couple of different assets turned on and off in the next couple of slides. So here we have roads and highways, and the map on the left, we have the Fathom-informed analysis, and the map on the right is the FEMA-informed analysis. So it might be quite obvious that in the Fathom-informed analysis, a lot more assets are shown as at risk than in the FEMA-informed. So for this Fathom-informed analysis, it identified 38% of roads and highway miles are at risk in 2020. That's the historical data, compared to 14% of roads and highways that are shown as at risk in the FEMA-informed analysis. It's really especially prevalent in DC, which is, of course, a densely developed urban area with a lot of opportunity for urban flooding. And so this is saying that there are 25% more road and highway miles that are at risk in the Fathom-informed analysis than in the FEMA-informed analysis. And so let's go to the next slide. We have here bus stops. So the Fathom-informed analysis identified 11% of bus stops at risk in 2020. And that's again on the left. And then on the right, we have the FEMA-informed analysis, which showed 4% of bus stops at risk. So that's a 7% increase. Next up is rail stops. And so on the left, Fathom-informed analysis identified 21% of rail stops at risk in 2020, compared to 7% in the FEMA-informed analysis. Again, I had to zoom in to show some screenshots here, but we have this data for the entire region. And I did want to also note specifically for rail stops and rail lines, this analysis did not factor underground versus elevated rail stops and lines. It's just not data that we had available for all of our providers across the whole region at a geospatial scale, but it does give an initial idea of what assets up top on the surface are most at risk to this type of flooding. And then lastly, next slide, we have rail lines. And so the Fathom-informed analysis identified 64% of rail line miles at risk in 2020, compared to 39% in the FEMA-informed analysis. Again, this is a bit of a more zoomed out, so you can see rail lines across the region. And so if you could go to the next slide. Oop, one more. Okay, so I wanted to wrap up this results section with an example of something that occurred over the weekend in our region. So on Monday morning, I sit down and I'm looking at all of the press that happened in our region from the flooding in Montgomery County and around the rest of our region. And I noticed an image at the top of a Washington Post article about the severe rain event with a flooded out car. And I'll show that on the next slide, from Saturday afternoon. And since the intersection signs were clearly visible, I thought, oh, I wonder what that's showing on our maps. And on the right, you can see the FEMA-informed original vulnerability assessment circled there in blue. And that's what the intersection looks like in that original FEMA-informed analysis, where that intersection is shown as at no risk. And then on the left, it is zoomed in a little bit, but the intersection shows as high risk in that FEMA-informed analysis. And if you could go to the next slide, I have the video or the image. And that's what happened on Saturday afternoon in that same intersection. So it showed to me that one of, I'm sure, many examples of this variance in the analysis from the recent events we've been seeing. And it really shows the importance of better understanding where issues might arise as we move into the future in a world that Sunny explained in detail in her last presentation. And so I know Montgomery County has a comprehensive flood management plan that they're working on, as well as some other products that they're working really hard on, and a lot of resources for residents to maintain safety in these events, which is awesome. So these are, I don't want to say they're freak events because they're happening a lot more frequently, and they will continue to do so, as Sunny mentioned. But as we continue all working together on obtaining better data, mapping the potential impacts, and implementing solutions, we can all sort of have better preparedness for these events in the future. Knowledge is power. And so next slide. As I mentioned, our mapping tool has been updated with the scenarios that are listed here on the slide. And I'll send a link to this tool when I'm done speaking. And you can toggle between all the various data sets and the scenarios on the tool, but I just wanted to make sure that it was noted somewhere here. It can be a little bit confusing when working with all of the different data sets. So in order for you to be able to see a thing showing up, every layer has to be clicked in order to view the risk score. So you'll see let's say the asset at the top, roads. And so roads needs to be clicked on, and then arrow drop down. You go to click on flooding and then drop down. And so here on this slide, I have the example of the Fathom informed data, and then the 2020 data has to be clicked. But if I wanted to see the FEMA informed, you unclick the Fathom and then click on the one that's right above it for FEMA. It takes a little bit of playing around to make sure that you get the right layer on that you want to see, but I just wanted to make sure that was written down so there's no confusion. And so next couple of slides, just some sort of thoughts and final takeaways. We were able to really provide a forward-looking analysis that was requested by our stakeholders to help the region better understand what transportation assets are at risk to flooding due to the precipitation, in addition to flooding near rivers and streams. And so we delivered that analysis using Fathom floodplain data to address this concern. Having this information can help empower our regional partners to evaluate resilience investments and transportation projects across multiple future scenarios and planning horizons for better decision making. And then lastly, we all know that more information can often make long-range planning stronger. So these results can help strengthen the region's overall preparedness and ability to adapt to future inland flooding challenges. And then finally, a few ideas for what you and your staff and some elected officials maybe could do for this new analysis on the next slide. So first and foremost, the results of this technical analysis can be used for awareness that really more assets just than those in the FEMA designated floodplains may be at risk to flooding both now and in the future. The tool can also be used as a resource for various policy decisions. So when resources are limited, more information can be quite useful when it comes to prioritizing projects for design and construction. So we can use it for that. It can also be used as supporting information and documentation for members when pursuing federal, state, or local funding. So more information about a site or a project's potential vulnerability can lead to better specificity in a potential grant application. And then lastly for today, I'm happy to, if anyone is interested in a more in-depth presentation or discussion of these findings, how to use the data in this tool, please reach out to me. I'm more than happy to set something up. I can come to your community meetings and we could bring up the map and we can sort of zoom in and talk. I'm happy to sort of work with anyone on any way for sharing this data, because I think it could be really useful. So that concludes my prepared remarks. I have here as the last bullet point, just sort of throwing the question out there. CEEPC, do you have any ideas for me on how we can use this? Any way that we can use this information to better help people make decisions, understand vulnerability in a different way? I'm happy if there's time for discussion. I'm happy to sort of hear anyone's ideas for how we can move forward with this research. And if there's time for questions, I can do that too.
Yeah, thank you. That was great. We have time for a couple of questions. I have one suggestion about how the tool can be used. I'm thinking about preparing in the very short run for what happened the other night, the other afternoon and evening, and knowing ahead of time what intersections are most likely to be problems at the very local level could be helpful, because otherwise it's, well, that flooded 3 years ago and that flooded 10 years ago, and this gives a better sense of these three intersections are the places we need to be paying most attention, because we may need to close roads, we may need to do things. So that's the short term implications of this. So there are a couple questions in the chat. I see Al, Elizabeth, and Dr. Olawale. So let's go quickly for those, and then because we do have the next presentation is going to take us probably longer than we have allocated. So Al, quickly, you have a question.
Yeah, I guess my question was, are there like rules of thumb or blanket statements, like we should never build certain infrastructure because of potential flooding concerns, or is it more of like a case by case? You have to look at the site. We have near where I am, a pedestrian underpass of railroad tracks, and certain options were rolled out, without even looking at the site. Does that make sense, or do you have to like really look at it case by case?
I think it's probably, I'm not a transportation engineer or a stormwater engineer, so I would say it probably needs to really be site by site. What this information in this mapping tool does gives folks in the region a general idea of what areas might be issues, and then we can sort of again look at that generally, and then if you've got a project in an area, it gives you one extra piece of information to say, all right, what does this say? What's the general predicted risk level, and then go for a specific more in-depth analysis on that particular location to sort of understand specifically from a generalized idea of what to focus on and what sort of area to do an additional study on. I see Elizabeth's question, is this mapping tool available to the public at large? It's available to the public at large. So when I send you the link, it's publicly available and anyone can use it or look at it. The only additional thing to note there is the tool has all of the analysis, the analysis that we put this data from Fathom through to sort of say, here are the roads, rail stops, bus stops, rail lines that we think are at risk based on the methodology that I explained. But we are not allowed to share the data that we acquired from Fathom because of the NDA. So I'm not allowed to share that, but we are allowed to share the calculation, the analysis that we did. So as long as you can't reverse engineer the original data, that's what we were allowed to share. So I will put that link in this chat.
Thank you.
So that's partially the answer to, this is specific to the transportation.
Yes.
Right. Okay. And so, Jeff, do you?
No, I think my question was, I said this is specific to the transportation infrastructure. Would you say this tool is applicable to other public or critical infrastructure?
Yes. I think that's a really great question. A lot of it is, there's critical infrastructure that some of our most vulnerable communities need to use in order to get to those places that are important, like hospitals, doctor's appointments, schools, emergency services. And so when you understand what transportation assets are at risk, you can also kind of understand, and I'm glad you asked this question, because it's something that I'm going to be working on in the next year, to sort of overlay this mapping tool with identified as critical infrastructure assets. So those types of places, and to better understand access to those places that may be hindered or harmed due to extreme weather or vulnerability. So thank you for asking that, and more soon from me on that.
Thank you so much.
Yeah, and Catherine, my question was related to, I noticed you'd had medium and high emission scenarios. Did you have any, and granted, we can play with it and see, did you have any quick observations? Like, are we expecting to see events?
It's not, the differences are not as crazy as I was expecting between historical and I mean, obviously the 2020 versus 2080 is the most, with the high scenario versus the medium there's the most variance. But it's not as big as I thought it would be.
And have you done anything with our public safety? Have you briefed any of the
No, but I would love to.
Logs group? Seems like they would be interested in it.
Yeah, I should reach out to them.
Yeah, that's a great idea.
I see Sunny's question.
Sunny's question. Yes.
Yeah, it's different. Flood map is different. And I'm not familiar with risk factor. But I think a lot of them are really similar. We also thought about, we compared Fathom with First Street when we were deciding between which data sets to use, which is First Street is just another similar private data provider for this type of stuff. I think they're all really similar. They have slightly varying methodology. Okay, First Street does risk factor. So yeah, they're really similar. We liked Fathom a little bit better, and we also thought that a lot of the information out there right now uses First Street. So I thought, oh, let's use a different company that's also equally reputable, to sort of see what the differences are. They're really very similar results. Yeah, those were the two main ones. And we just ended up going with Fathom because we liked a little bit better their transparency. So that's one of the reasons.
Thank you.
Thank you.
And so last call for anyone who has not spoken or put their comments in the chat. Okay, hearing nobody speaking up. Thank you. That was great. That was really interesting and very helpful. And to another, and you'll be available because you work for COG. And you'll put the two products in the chat with your information. Great. And so let's, while you're doing that, let's move on to our next presentation and conversation here about the greenhouse gas, mid-review of the greenhouse gas inventory and where we are in terms of our regional goals. So I'd like to welcome COG staff member Maya Davis, who we all know and appreciate already, and she'll brief us on the results. This is one of the key pieces of the mid-course review that we're working on this year. And many of you have submitted comments and questions already, which she will try to address in her presentation. And I'm thinking of this as a work in progress, and Maya will cover all of that. Take it away. Thank you.
Great, thank you. Fantastic presentations, really informative this morning. So we're going to talk about the next aspect of the mid-course review, which is the 2023 draft greenhouse gas inventories. We sent each local jurisdiction, each COG member local jurisdiction, their draft local greenhouse gas data summary spreadsheets this past Friday. And the COG regional draft greenhouse gas data summary sheet is posted to your meeting documents online that we shared earlier. We're going to provide a broad overview of the methodology and results, and we're happy to answer questions today, but we already have many one-on-one meetings scheduled with local jurisdictions where we can dive more into your local results and questions. Next slide, please. So just wanted to give an overview of where we're at. So the mid-course review, we're looking at how are we doing towards meeting our 2030 goals and the 2030 plan. And also this work is helping to inform our Climate Pollution Reduction Grant Comprehensive Climate Action Plan, or CEEPC. We'll be bringing you more performance indicators through the rest of this year. Next slide, please. So the greenhouse gas inventories have directly been able to show if we are meeting our local and regional greenhouse gas emission reduction goals. This slide shows the regional goals, and our inventories were able to show that we did meet our first goal, which essentially was to get back down to 2005 levels by 2012. In the last round of inventories, we showed that we did meet our 20% below 2005 levels by 2020 goal. And you'll see today that we're borderline at that 2020 goal as of 2023. And then the next goal that we're working towards is 50% by 2030. Next slide, please. It's been more than a dozen years since this body, CEEPC, as well as BIAC, asked COG staff to track local and regional greenhouse gas emissions for our member communities. So we do these inventories each time for 24 local government member jurisdictions, the Northern Virginia region, as well as the Metropolitan Washington or COG region. We have done these inventories for 2005, 12, 15, 18, 2020, and now 2023. So in total, we have developed more than 156 community scale greenhouse gas inventories for the region. And over these years of doing these inventories, we've coordinated with hundreds of experts and stakeholders to support this work, and we wouldn't be able to do it without them. So I just wanted to take a moment to recognize some of these folks, particularly Alyssa Boggs and Tim Masters from our team, who've worked day in and day out with me over the past year and a half to get to the point today to share these with you all. We also typically work with 15 to 20 experts within COG across 3 different departments, everywhere from transportation, air quality, wastewater, forestry, solid waste, ag, land use, demographics, and we use data that those sectors are using for their local planning. So this data has been vetted internally by these sector experts. A lot of it has been vetted through our local government committees focusing on these sectors and published by COG as well. These inventories would not be possible without working closely with the 9 energy utilities across the region, and we've been working with them annually on data collection and analysis since 2009. We also work with local jurisdictions and MVRC on the solid waste data in particular. ICLEI's been a strong partner, and we use their tools and have helped develop some of their tools like ClearPath, Learn, and the contribution analysis tool that we use for this work. And this year we've coordinated with ICF to develop a methodology to calculate data center electricity emissions and also to verify some of our forest and tree findings this time around. So this is not done in a vacuum. This is done with all of you all here and many technical experts. So just wanted to thank everybody. And everybody is certainly not on this this slide, but there's some 4 people we worked with to support the results this round. Next slide, please. So we have worked really hard to ensure that the inventories we produce are compliant with both the US protocols as well as the global protocols for community scale greenhouse gas reporting. We've worked with ICLEI and the Carbon Disclosure Project, as well as the Global Covenant of Mayors to ensure this, and we have been verified a few times, once by ICLEI and twice by the Global Covenant of Mayors, to have met these US and global standards. Next slide, please. So we track these inventories. We do these inventories to help track progress towards local and regional climate goals, as well as to support your local decision-making around policies and programs for climate and energy. And we really focused on some core values here, which we focus on making sure that there is completeness, consistency, accuracy, replicability, transparency, and quality control. And since we use the same methodology across all the jurisdictions, all of the results are comparable to your other neighbor communities in the COG region. The protocols require three main sectors essentially, which are buildings, transportation, and waste. Stakeholders and members asked us to add agriculture maybe 9 or 10 years ago. And then for like about 5 years, we worked to incorporate carbon sequestration to provide a net emissions estimate as well. So these aren't required in the protocols, but we incorporate them because the stakeholders have asked us to. The main gases that are addressed here are carbon dioxide, methane, and nitrous oxide. But in the process and fugitive emissions, we also have some HFCs and PFCs. Recently, we were asked about sulfur hexafluoride, SF6, and nitrogen trifluoride, NF3. So I just want to address that here for a second. We did include SF6 in our CEEPC greenhouse gas inventory for the MSA. They aren't in the inventories you all have received. It's not necessarily required. It's a fugitive emission that looks at electricity transmission and distribution. If there is broad interest in us adding that is something that we can do. It's a fairly simple calculation. NF3 comes from the electronics industry, and we have not calculated that in the past because that is considered not a significant source in the region for the protocols. We do have one plant in the region that we believe produces those, however. So let's move on to the next slide, and I am going to pass this to Alyssa Boggs from our team to go over some of the high-level results, and then I'll come back and explain a little bit more about the methodology and next steps.
Thank you, Maya. So yeah, we'll get into the data, into the weeds a little bit. So the region decreased gross greenhouse gas emissions by 19% between 2005 and 2023, and net reduction of 20% between 2005 and 2023. On this graph to the right, we can see 2005 on the very left, which is our baseline year, and then we have 2012 and 2020, which were our goal years, which Maya said a couple slides back. And then we have 2023 on the very right that we can compare with the previous years. And while 2023 emissions are a bit higher than 2020, we did expect this due to the post-COVID rebound. So in terms of gross and net, historically, we just were reporting gross emissions without forests and trees. But in our last round of inventories in 2020, we added the whole forest and tree sector. So this included forest and trees emissions, which you can see in that top very, very small sliver. I don't know if you can see my mouse, but that very small sliver at the top is forest and trees emissions. And then the light green at the bottom is forest and tree removals. So now our gross number includes all this positive plus forest and trees emissions. And then the net number includes all of it, so those sequestration numbers. Sorry, the sequestration numbers are also included in that too. So the net number is a little bit lower to offset those emissions. So in this presentation, we're presenting both statistics, gross and net. But in the Global Common Reporting Framework, they really just report final net emissions, which meets international and US protocols. So in our final reporting, we can just focus, we can just report the net number as the final number, or we can share both depending on the collective preference of CEEPC. No need to make a decision today, but please share with Maya and I if you have a preference. Our emails will be at the end of this presentation, of course. All right. So here's just a few statistics that put into perspective what an over 14 million metric ton of CO2 equivalent reduction looks like. We have over 2.9 million homes off the grid in a year, over 232 million tree seedlings grown for 10 years, over 4.9 million tons of waste diverted to recycling, over 3.2 million gas passenger cars off the road for a year, and over 15.6 billion pounds of coal burning avoided. So I think when you put it like this, it's definitely something to be proud of. So now we're going to dive in a little bit to 2023 by sector. The total gross emissions in 2023, so this does not include any removals, came out to 61.6 million metric tons of CO2 equivalent. So you can see this orange part of the graph, both the light and dark. This is the buildings sector, which accounted for the highest percentage of emissions at 49%, which includes electricity, natural gas, as well as fuel oil and LPG in the residential and commercial sectors. As Maya said previously, as part of our comprehensive climate action plan, ICF helped us create a methodology to break out data centers from the larger commercial electricity sector, which Maya will be speaking to the methodology a little bit later. But you can see here that data centers accounted for 9% of regional emissions, which is that dark orange piece of the graph, with all other commercial energy accounting for 23% of regional emissions and residential energy at 17%. Now we'll go look at transportation, which is the second largest emitting sector in the region at 41% of total emissions. 33% of total emissions is on-road transportation, 3% is off-road, 4% is passenger air, which is based on passengers originating at DCA, Dulles, and BWI, and less than 0.1% for rail, which is from diesel consumption of VRE and MARC trains. And then in that last 10% chunk, we have 6% to the other category, which is process and fugitive, as well as agricultural emissions. And then 3% is waste, which is solid waste and wastewater. And then we have 1% to forest and tree emissions, which is those deforestation type activities. So here we can see the jurisdictional breakdown of all the COG members' percent change in gross and net greenhouse gas emissions between 2005 and 2023. You can see, I'm not going to go jurisdiction by jurisdiction and read out all the percentages for sake of time, and don't want the repetitiveness. But you can see, I think an interesting point is that the jurisdictions that have more land area for forests and trees, the difference between gross and net emissions is definitely more dramatic than in the smaller, more urban jurisdictions that don't have any forests or room for forests. And then also it, I guess, makes a little bit less of a difference if you cut down some trees because there's not as many to begin with. So this is the same number, but in a graph form of the gross emissions. So we can really visualize the percent change. Here we have it from greatest decrease to greatest increase. Again, not going to go jurisdiction by jurisdiction, but we have a majority of the jurisdictions in this 20 to 40% reduction zone. So that's super awesome. And now this is per capita emissions by jurisdiction, which is metric tons of CO2 equivalent per person. So by looking at this sort of statistic, we can get a little bit of a better apples to apples comparison when looking at jurisdictions of different sizes. Of course, I'm not saying that the population of the jurisdictions at the top are less environmentally conscious than at the bottom. There's obviously a lot more different factors that go into it, but population is a huge factor on emissions in a jurisdiction. The regional per capita for 2023 was 10.5 metric tons of CO2e per person, which is a reduction by about a third from 15.6 metric tons of CO2e per person in 2005. So when we calculate the emission from electricity, which is a huge section of our emissions, we take the consumption, which is a big chunk, but then we also need to see how clean the grid actually is, because if everything's electrified but the grid is dirty, you know, it's not great. But so here we have the eGrid sub-region emission rates divided by RFC East, which serves DC and Maryland, and then SRVC, which serves Virginia. You can really see how clean the grid has gotten over the years. In 2005, for both subregions, the CO2 pounds per megawatt hours is over 1,100, whereas in 2023, for both subregions, it's under 600. And this can mostly be attributed to coal power plants retiring, and more natural gas, and a smaller extent, renewables are reducing our emissions from electricity. And I'm gonna pass it back to Maya to take us home.
Thanks, Alyssa. So it's important for us to recognize the methodology updates that we do each round. I'm not going to speak to each of these. These will be fleshed out further in our methodology report that we'll release at the end of this year, but I do want to point out a couple of things. We have updated our global warming potential values for the base year and the most recent year to the IPCC Fifth Assessment Report, or AR5. In the past, we've done it in AR4, which is the Fourth Assessment Report global warming potential values, but the main difference is in the nitric oxide value. And so it really doesn't affect the overall results too much. It's about a 0.5% or less difference when you're comparing total emissions from AR4 to AR5 in your inventories. We did a sensitivity analysis on that. So in a lot of cases, it's less than 0.1%. So these are very comparable across the years. And when you update your global warming potential values, it's pretty typical to do your first year and your most recent year for these. So when you're comparing that percent reductions that Alyssa just went over, it's an apples to apples approach. We also updated the AR5 across all of the years, because all of the years for on-road in particular, because for all of the years we were updating to MOVES 4 across all of those years. So we updated those to AR5 as well across the years. We have actually gotten a lot of questions just since Friday about data centers. So I want to take a moment to talk about that. We did provide electricity estimates for data centers for both the 2020 inventory and the 2023 inventory. If we go to the next slide, I can speak to that a little bit more to address some of these comments that have come in the past few days. So we've been coordinating with local jurisdictions that have data centers in them since last fall as part of our CPRG project, and looking at how do we address data centers in the Comprehensive Climate Action Plan, or CCAP. We also had discussions with this project steering committee, BIAC and ACPAC. And what stakeholders essentially asked for is to do greenhouse gas estimates in the inventories, as well as greenhouse gas projections for data centers, and to develop a data center measure. So where we started with this is we sent a survey last fall to all jurisdictions and asked them questions about the permitted data centers, the planned data centers, as well as growth expectations for data centers. We leveraged reports like Dominion's 15-year data center plan and their 2023 integrated resources plan to inform the estimates. And we did, so you all know, for the stakeholders on the call today that have seen the previous earlier results back in the spring, for many of you, they look a little bit different. We did refine the methodology after speaking with all of you all to consider the energy use intensity of standard data centers versus the energy use intensity of the hyperscale data centers and the data centers that are utilizing AI. So if we go to the next slide, we can look at a little bit of the results here. So the estimated square footage of data centers across the COG region is 46 million square feet. And 43 million of that is estimated to be in Northern Virginia. We estimate that 25% of total electricity consumption in the COG region is used by data centers, and about 5.5 million metric tons of CO2 equivalent we're attributing to the data centers, which, as Alyssa mentioned before, that's about 9% of total greenhouse gases in the region. We have noticed significant expansion in data centers just since 2020. We've noticed that through the energy utility data that we get, as well as through the square footage data. So we saw that in 2020, the square footage for the region was about 28.9 million. So that increased to the 46 million that we see just 3 years later. And then the emissions have actually estimated to increase from 2.16 million metric tons of CO2 equivalent in 2020 to more than double at 5.5 million metric tons of CO2 equivalent in 2023. And can we go to the next slide, please? We didn't want to leave you today with just these greenhouse gas estimates that we have for data centers. We wanted to leave you with strategies to address these issues. So we have a draft data center measure that was developed with these stakeholders and ICF for the CCAP. It is draft, and it is posted to your meeting materials online. It goes over just data center types, sort of a snapshot of data centers in the region, and then gets into these action areas such as IT equipment efficiency, cooling and air management, on-site clean energy, tracking and reporting systems, as well as engagement and advocacy that can be done in the region. And so I'd really encourage you all to take a look at this draft measure, and we would happily accept additional comments on this measure through Friday, August 8th. And if you want to dive into this more at your next meeting, the estimates, the projections, the measure, we can do that at a future meeting as well if you're interested. Next slide, please. So quickly, we have been, it takes about a year to year and a half after the calendar year you're inventorying to get all of the data, for all the data to become available for us to do these calculations. So it's typically a 2-year cycle from start to finish. We have, as I said, we provided the draft inventories to everybody. We have a comment period during August. We will do final edits. We can also help you if you're doing CDP reporting. Please let us know, and we can help you get the additional information you need for that reporting. And we'll do a drivers of change analysis and then develop fact sheets. And so by December, you'll have your final data summary spreadsheet, final fact sheets, final contribution analyses, and final methodology report. And the fact sheets and the methodology report will be published on COG's website. And if we, and again, local jurisdictions, when we go through this comment period in August, they review the information as in different ways. So we have some jurisdictions that just keep the review to their climate and energy team. Some jurisdictions share internally across departments and discuss and review. And then we do have some jurisdictions that hold like a community meeting, like bringing this to your citizen sustainability committee. And we'd be happy to join virtually to that to help answer questions if you do hold a meeting like that, or you can collect their questions and comments and submit them to COG separately. So if we go to the next slide, this is the last slide. For those of you who aren't familiar with the contribution analysis, this is a high-level result from the regional analysis, the last round. This is not updated yet. We will update that in the fall. But essentially just wanted to give you a sense of what this is. What we're analyzing is why are emissions changing between inventory years? And for everybody, it's typically like, okay, population has an impact on emissions growth, but you know, the cars are getting cleaner, the grid is getting cleaner. And then from there, it's sort of, you know, can be different across jurisdictions, but those are generally the results that we find from this analysis. We're also interested in trying to tweak and leverage this tool to look at a few jurisdictions who have data centers and how those impacts of data centers compare to other impacts that influence the greenhouse gas inventory. So with that, we'll go to the last slide and just remind you of a couple things we mentioned today. If you have thoughts about us reporting gross versus net or both, if you are interested in electricity transmission and distribution emissions being calculated, and lastly, if you have any comments on the data center measure, to please submit them to us by Friday, August 8th. And with that, Madam Vice Chair, I will pass it back to you.
Thank you. That was really, really comprehensive, and the amount of staff work that goes into this kind of a presentation is huge, and I really appreciate it. Individual questions about individual communities, let's have them go directly to Maya and Alyssa rather than talk about them now. We can take one or two questions about the overall slides. Lindsay has one, and I have one. Lindsay writes, she sees an increase in commercial floor area, but is there any consideration of vacancy rates, which might across the region? Are they included in other decreases or somewhere else?
Yeah, so we didn't analyze vacancy that last round. And
Okay.
I would say that these results that we had for 2020 are different than what we've seen before because of pandemic impacts. Like vacancy might be influenced by that first smallest blue bar that's decreased commercial kilowatt hours per square foot. So that's where we thought that vacancy in the pandemic might have played a role in that leading bar right there. But we don't there isn't like something specific for vacancy in the model to analyze. But I do expect the results to be a bit different this year.
Yeah, because of vacancy rates changing. So the other questions in the chat were about data centers. My question is about transportation. We talked about what COG might be working on it to get data centers greenhouse gases down. What's your view on making the 2030 goal in transportation in particular? What more do we need to focus on?
So right now for the comprehensive climate action plan, we're working on an updated scenario. It's a net zero emissions scenario. So you all know that our adopted goal for the COG region is 80% by 2030, but we are analyzing what it would take to get to a net zero emissions by 2050. And so if that's of interest to you guys, we could bring the results of that to you in at the September meeting. We'll be releasing that plan for public comment in October. And we do, you know, have it kind of broken out by sector in terms of like built environment, how can we get there, transportation, how can we get there, et cetera. And so we're still doing internal reviews on those drafts, but we'd be happy to bring those results if folks are interested in that.
I can't speak for anybody else, but I think it would be important for CEEPC to look at this as well as TBB. Any other comments, questions before we move to our last agenda items?
Yeah, I had a question.
Matt.
Oh,
Go ahead. Go ahead. You first.
oh, thank
Dr.
you.
Ololo. Yeah.
Yeah, thanks for the acknowledgement as well. I really appreciate the work done. I know it's a whole lot of data hauling. But question I had was, could you speak a bit on how you may have accounted for diesel use in data centers? on site, because I know that's a thing. And also, I'm just also curious because with e-grid, the sub-region emissions rate, I know that's accounting for what the grid mix is, supposedly using RECs, solar, wind, and the likes. And we know that a lot of these are sometimes also, I want to use the word, more like claimed elsewhere. And I'm just trying to reconcile how residuals, offsets, or RECs by fuel type was handled. This is something we could definitely talk offline if that's something preferable, but I'm just really curious for the knowledge of every other person how diesel use for data centers were handled and how different fuel sources and sourcing methods were accounted for.
And a related question, I think, from Matt in the chat, with increasing electric demand, primarily from data centers, are you surprised to see the grid emission rates still getting cleaner? So can you talk to those 2 points?
Yeah, so we did we get commercial electricity data from the utilities, and we had a methodology we have been refining over the last several months to estimate what portion of that emissions is from data centers. We did not specifically do like natural gas or any other part of data centers, just the electricity emissions is what we called out. And where I think that like diesel backup generators would be captured in the inventory is probably in our off-road emissions, but not called out by data centers versus other sectors. It's just community-wide there. And as far as the grid, so the only thing that is counting towards emission reductions in the grid is what is happening in these grid regions that cover our region. So if somebody has like a power purchase agreement and they have that in, let's say, southern Pennsylvania, that would already count towards the grid reductions that we're capturing in the inventory. But if they had a power purchase agreement with somebody, in Texas, that would not count towards reduction. It has to be local, or we're not seeing local benefits. So those aren't counted. So I hope that helps with that question. I'm not surprised to see that the electric grid is still getting cleaner. There are a lot of clean energy projects that are happening in the region, and the data centers, we don't have a complete picture, but they are putting in a lot of solar in the region as well. I think like Amazon has like 12.5 solar farms that they have put in to offset their emissions in Virginia. So I'm not surprised that we're still seeing the grid getting cleaner, but because we're still seeing such an increase in consumption of electricity, that can offset how clean the grid is and the impacts. So the two key things that go into that is how clean is the grid and how much consumption we have. And so one can offset the other or cause a problem.
And so Jeff makes a comment in the chat similar to this, that data centers are both driving electricity demand growth, but they're also driving the deployment of grid scale solar. And so that's an interesting tension. And I would think in a future meeting when we talk about the data center write-up that you want us to comment on, that we might want to comment on whether and how to capture the notion that many, but clearly not all, large data center operators are offsetting their emissions when they build. So we're running out of time here. There's a couple more things in the grid, in the chat that people can look to. Maya, could you say again when you want comments on what? Just to clarify.
Yeah, on the data center measure, it'd be great to have comments by Friday, August 8th, because
Okay.
we'll be starting to do more writing on the full plan in August. And anytime till the end of August, we can take any comments that you all have on the greenhouse gas inventories themselves.
Okay, so a little bit of homework over the summer here. Sorry, guys. And that was all great. And I know you'll be available for questions if anybody wants to email you with general questions about the region. And someone's put the JLARC study from Virginia in the chat for people who want to go in more depth on that. So thank you. And so moving to our last topic, which is many little topics. This is our time for member updates, committee updates, and staff updates. And just to make sure that the staff get the quick report outs in before noon, let's have them go first, not last. So who would that be? Would that be Jeff or Maya or Lynn or Ms. Boggs? Jeff?
Did you want to
Sorry.
say a few words about CFI? Or CPR?
Whatever those things were that you wanted everybody to know before the end of the meeting.
Sure, I'd say CFI is going well. We've partnered with 7 jurisdictions in the Clean Cities Coalition, and we're in phase 1 of planning and looking at NEPA requirements and site designs, and we're starting to coordinate on doing community listening sessions as well as the EV job fair this fall under that grant opportunity. So more to come on that in the fall.
Okay, anything else from staff? All right, let's go to members. Maya, could you please help me to see who's got their hand up? Anybody have an update that they would like to share about what's going on in your community? I love this part.
I believe Al Carr probably has an update about the
Great.
Energy Committee, maybe for DC as well.
All right, good morning. Thanks, Cindy. Thanks, Maya. I'm Al Carr. I'm the chair of the Built Environment and Energy Advisory Committee. A BAC's June meeting, we got a briefing from ICF on the Comprehensive Climate Action Plan's data center measure that includes actions local governments can encourage data centers to take to improve energy efficiency and reduce emissions. The goal is to provide actions jurisdictions can leverage to maintain the economic advantages data centers provide while addressing concerns of how to balance rising greenhouse gas emission reduction goals. 2 interesting recommendations from the measure are that although data center loads are typically not flexible enough to participate in demand response, they should consider collaborating with utilities to host on-site grid-scale batteries. Also, district energy systems should be considered in planning for new data center campuses. BIAC also heard from Electrify DMV, formerly known as Electrify DC, a local nonprofit incorporated in DC and Maryland, soon to be in Virginia, focusing on decarbonization of the residential sector to make it easier and more affordable. Their core program is the Residential Electrification Implementation Working Group. It includes local governments, service providers, industry experts working to scale residential electrification. And the group specifically works to establish better collaboration, pool resources, best practices, and align programs and incentives. They're looking to increase participation. So that's all I have. Our next BIAC meeting is September 18th. Thanks.
Thank you, Al. Holding for a minute on individual member updates, let's just go through the list. In your packet, which is online, there's a summary of a number, maybe half a dozen of the committees have sent in a little blurb that you can read, and I already did, and they're very useful. Is there anybody else, legislative committee, Air and Climate Committee, regional EV deployment, regional clean cities, recycling, tree canopy, any of the other committees want to speak up to amplify, or if you didn't get your paragraph in?
This is Bill Wash. Oh,
Go
Great.
ahead, Bill.
okay. This is Bill Washburn, Chair ACPAC, and I just want to thank you for this opportunity. I'll just start out by mentioning that ACPAC met this past Monday, the 21st of July, and at that meeting we received a briefing on phase one of the EJ Toolkit update that was first published by ACPAC in 2017. The first phase of that refresh was the community engagement element, which the company Equinol led, and they're the consultant that we secured to engage the community on environmental justice issues. And their findings were submitted to COG staff at the end of June, and staff presented elements of their report. The final phase will be to merge the community engagement findings with findings from COG's engagement with local government EJ staff into a single report with recommendations and best practices. We're hopeful that the final EJ toolkit will be completed by the end of this year. And finally, the 2025 Climate and Energy Leadership Awards campaign ended ended on June the 30th. This year, the campaign received 23 applications from a variety of where they received 23 applications. And I want to thank our staff liaison, Leah Boggs, for her consistent hard work on the campaign and helping to get upwards of 20 applications each year. I also want to thank the members of ACPAC who helped out in reviewing those submissions and coming up with nominations for winners in the 5 categories: small and large governments, NGO, nonprofits, for-profits, and educational institutions. And we will be announcing those winners at the October COG board meeting. If you have any further questions about the Climate Energy Leadership Awards, you can get in touch with COG staff Leah Boggs. Our next meeting will be on September the 15th, and that wraps up my ACPAC update. And I want to thank you for this opportunity.
Thank you very much, Bill. That was very helpful. Who was trying to speak when Bill spoke?
That's me. I'm going to provide a
There you
brief
go.
update on the Regional Electric Vehicle Deployment Working Group in
Great.
the absence of our chair. We had a meeting last Thursday, the 17th, and we had presentations, one from EPRI on their EVs to Scale 2030 initiative, which is designed to address barriers for EV adoption at scale. They had 2 things of particular note from that. One is a vetted product list, which includes items that are NEVI compliant for those in the region that are trying to meet NEVI requirements. So you can go and look at their spreadsheet, which they update regularly. And then also they have a grid load tool, which might be of use for our members. And then there is a presentation from the Massachusetts Clean Energy Center on their V2X, or Vehicle to Everything pilot, which is designed to improve grid resilience by paying folks to charge their cars in like off-peak hours and be able to use their cars as temporary batteries to improve grid stability. And our next meeting will be on October 16th. Thank you.
Great. Other committees? Anybody else? Individual members that want to report on specifics from your community? We're moving into the home stretch here. Maya, do you see anybody with their hand up? And does anybody?
I
Maria,
don't
do
see any.
you? Go ahead.
Sorry, I just was saying I don't see any hands.
Okay, last call. Okay, well, thank you to all the presenters and especially to COG and TPB staff for doing such an excellent set of presentations here. It gives us a lot to think about. And there's a couple things we want people to do over the summer. The next virtual meeting, it will be a virtual meeting, is September 24th at 10 a.m. The last meeting of the year is November 19th. Is that a firm? Is that?
Yeah, I recall, and it might have been you, there was a conflicting meeting with, I want to say
Yeah.
the National League of Cities. There's some meeting that's
Right.
happening, and
But if that's just me, then we're not going to worry about it. Yeah.
it'd be interesting
Okay.
to look into whether or not there's a kind of a critical mass of folks who may have a conflict on that date and consider rescheduling, but we have some time, so we'll work on that offline.
Okay. And hearing nothing else without objection, this meeting is adjourned. Have a happy day and a good lunch.
Thanks, everybody. Enjoy your summer.
Thank you.
Thank you all. Bye-bye.
I am staying on for just a minute if there's still somebody left from COG.